Okay, welcome to the second companion video for the basic introduction to electronics. So before watching this one, you should have gone back and watched the first hour and a half lecture on the basics of electronics, and I would suggest watching through also the simulator version of this. I am going to do a lot of the similar things that were done in the simulator, but not every step. It's a little bit harder when I'm working with physically everything on the desk here. But this gives extra, and even if you're just watching the simulator, you should watch this as well. And I don't know why I said that, because if you're watching this, you're already watching this. Your teacher's insane. Okay, so we have the physical components. I apologize in advance for any kind of shakiness with the camera. I have limited setup here to be able to do things stably. But you have all the physical components. You have everything else there in front of you to actually deal with. And if you got the kit itself, which good luck if you're getting everything back into the kit easily. It's a small box. It's hard to organize. So you have a lot of the stuff that you would have seen in the slides here, the physical components. You've got a lot to play with. And I'll mention one thing that you wouldn't have seen in the simulator and the other kits is things like this is the example, the Freenova version of the Arduino that for the kit I suggested right now and I'm using. But really you can use any Arduino. It doesn't matter. Just get an Arduino Uno, whatever version you're working with. Now if you've never dealt with it before, a lot of this stuff will come in this plastic casing. So remember, this is meant as an insulator and also to stop things like static shock. Static shock while you're working with stuff can destroy some electronics. So things like walking on shag carpets or building up other stuff and touching components, you can spark stuff, which then would put a surge through that could destroy things. So when they package all electronics at the beginning, they just put them in these protective kind of shock-proof cases that you can rip them out and take them out. But for this video, we are not using this right now. We are just going to go straight with some of the basic electronics that we have right now are power sources. So I just have a 9-volt I bought. In the case, you would have gotten one of these connectors, which allows you to connect a 9-volt. Just to make it easier, it should be one way to connect it in, but gives what's called a barrel plug on the other end for plugging things in. You also then have this little battery case, which allows you to put two AA 1.5 volt batteries, putting them in series, and then giving you two slot connectors that allow you then, I can connect and use other jumpers to connect to the boards as I see fit. You also then have this little board here, which is to help give you extra power in multiple different ways. So kind of managing the power. It plugs into the breadboard, has a little on-off switch right here, which allows you to turn the circuit on-off. You have a little plug here that you can put in the barrel jack for the 9-volt. You also have a USB plug right here that you can plug into your computer or a cell phone charger or anything like that. That will help provide the 5 volts, usually around 1 amp or more, depends upon what you're doing, which source you're coming from. But the rest of this ends up regulating it for you. And then you have these other connectors here, jumpers or things that then plug into the board. So I'm not going to start with this, but we'll come back to how you can then use this if you wanted to connect it up. In the future, for some stuff, we'll be starting with the Arduino to use what power sources it provides, but I wanted to do some just base electronics not using the Arduino to begin with. Boom. So leave these all before, we'll connect everything together, and you have some other components in front of you that we have. Hey, look, like a ton of different jumpers. You can see this is the M to M kind. They both have metal pins, the plastic cover, the insulated wire to help remove that you don't remove short circuits, anything, and then the arbitrary colors that you can use. So the kit comes with a whole bunch of different sizes and colors. You will also get what looks like these ribbon color cables that are just other jumpers. So you can see this is that slot to slot or F to F that allows you then you could take a jumper like this and plug it in, so that it just slots in, and in there it's going to end up making metal-to-metal contact as you're dealing with this if you want to connect stuff together. When using these, you can leave them together as you see fit, or you can strip them apart. I generally like to leave them in the ribbon for right now until I know what I'm going to use them for. And here you have another example of the slot, and then the pin to plug in. So again, these are your jumper cables, are wired, building, helping connecting stuff in your circuit, making it easier when using the breadboard. So these I will just kind of leave off to the side so it's not always a chaotic, crazy mess in front of me. You also have a nice little resistor sheet if you want to use that or use a program online. You have these resistors that should come in the pack. So you have, boom, right here. You have the resistors themselves on these little metal leads. And on most of them, they will also, we'll get this in focus, is they'll just say what ohms they are. You can again read from the codes, and little card helps you how to read them, how to figure it out. But for right now you have these, but the problem is once you start pulling these out and you throw them back in the kit, trying to figure out what's what. So another good idea would be to maybe when you're using these, try to keep little baggies and put these back into separated ones just for easier use in the future, so you're not digging and trying to read the codes, which on these ones that are blue, it's kind of hard to do. So set those down. You then also have your LEDs right here. You can see that. And so plastic coating for the color. You have the connectors afterwards. And you have the general convention, which is hard to see here. But you have one lead that's longer than the actual other one. So this is your anode and this is your cathode on the actual diode. So I'll put this down lower and you can probably see it better. So the longer one is your anode, the shorter one is your cathode. A couple of those. You have different size buttons that you can use. And here's an example of just a diode. And remember, the diodes restrict the flow of electrons to be one way. And you can see again from right here, it's going from positive, flowing negative and won't go back. So you have your anode and you have your cathode and you have that little line there that's the indicator. So we're not using any of these. I just thought I'd bring it out so you can see the physical materials and things you can work with. Now, when working with all these, you get these really long leads. The idea is they're meant to be so you can plug it into the actual board. You can see it there. You can then bend it, but you don't want to be too crazy. Try to be gentle with them and using force of what you hold. So don't just take this and shove it in randomly. Just try to take one side and work with it. But we'll just put that off to the side. Boom. And we'll put some of these LEDs off to the side in the future to see. And have our resistors up top there for access. Other than that, again, you have your breadboard, your trusty building circuit. So this one's a little bit longer. Sometimes they just come in half size, but it's still that same idea that you have. What's marked here is that these outer rows, that one here is all connected together. So the plastic insulator, you got metal inside the holes here. You got your negative on both sides, and then you have these rows here, which are all connected together. So this are all connected one row, but from here to here is not connected until you make that connection and what you decide to do with your circuit itself. So with all of these, I think just to start with, I want to do it without a breadboard and see how this goes. It'd be interesting doing this live is that, again, we have our power source. So in this case, it's two 1.5 volt batteries that are going in series. The idea is from right here, you can see again, they've got the convention black for negative, red for power, going to the actual slot connectors here just for us so that we can connect other things to it as we see fit. But then you can see again, it's going to flow and go to the negative. So in the battery itself, you can see internally the posts, which here are supposed to be positive, and then this being negative. And so the flow coming out from here is that you're going up, through, and back from your negative. So this is part of here. We have our power source. We have the beginning. It's an open circuit right now. We haven't connected anything else. So I want to connect the rest of the circuits, but I don't want to start connecting stuff to the power yet, because as soon as we connect stuff to the power, it starts running. So we want to start connecting the rest of our circuit. And again, I'm just doing this without the breadboard, just a demo. You don't need the breadboard for the circuits. It just makes it so much easier since this is going to be kind of a chaotic mess of me holding stuff and seeing how this goes. So first off, we need to have a resistor. So I don't want to just put this straight in and then have it go crazy. Or do I? Because there's a video, we can see what happens. Let's just see what happens. It's me. It's this fun side. I don't need all of the LEDs, so I'm going to take another one from the kit. I have other ones. So please don't do this yourself, because you're just going to end up destroying an LED. from here. What I'm going to do is that first level is that I've got my, I'm going to move this one off here. I've got little sacrificey. I shall call it sacrificey. Hello, sacrificey. So I'm going to call that my sacrifice LED because I'm going to have to throw this out afterwards. So again, on here I just bent these apart, but we have the LED, we have the anode, and we have the cathode, and it's just convention that the anode's always longer when you first get them. And these are the leads coming up into the actual part that will emit the LED. So the idea is that you're supposed to have positive come up through here and the negative come down. If you reverse that, it won't flow through. It's only one way. And this can only handle a certain amount of amps or current. You saw on the simulator, it just showed a little psh sound from right here. This will probably do nothing. We may not be able to see anything at all. It just won't work coming out of it. And I'll leave sacrificing and we can try it later potentially. So now when I come to the actual battery itself, I can start reading the posts that we've got positive being the round post and we've got negative being here. So when negative, positive, anode should be going here, cathode should be going here, and I am just going to do here. Now again, I'm trying, like, you're okay to do this because it's such low voltage and I'm completing the actual circuit. So again, positive, negative, anode here, cathode here, boom, overall. And if we just try to connect the actual LED, nothing. Like, it won't light up. You probably won't see anything, but this is most likely not going to actually work anymore after this point in time. That it can't handle that. We'll see. Nothing happening there. So we don't see anything. It didn't do any pop. It wasn't anything too high. And try it again even on the other one. Of going to the other battery. And things popping out. Okay, so anode into positive, negative. Put this in. And yeah, you didn't hear it, but I definitely heard it that time. There was a little tiny pop. So in this case now I've connected it in. It is then a complete circuit. It's completely running through, but then the amps, and you didn't hear it. Nothing happened as it came up here, but there was a little tiny pop. And like this LED is basically sacrificed and screwed. And like again, if you do that, I'll leave a little sacrificey over there, is then you've got that screwed. You can't do anything with those. So you want to be careful, and you want to add in that resistor in between. That we need at least something to lower the actual current so that the LED will work properly. So I am just going to take a 220 ohm resistor, just following what the actual tutorial suggested. And I'm going to start building the rest of the circuit. So I'm not going to hook up the power first. I'm going to hook up everything else together and try to do it easy enough. So the thing is, I at least want to start having that, okay, from the cathode's going to be connected over to here, and we're not going to use the 9 volt. We're going to use this one here for right now, just arbitrarily, is that I want the cathode, the little one right here, connected to the negative over here, and this is a slot. So I'm going to find one of the jumpers here that allows me to have a slot for one side for the LED, and then on the opposite side allows me to plug it in for the cathode. And I'm going to keep the convention of using a black cable for the negative. So I've got it here. Taking the slot and making sure I've got the cathode, and then just sliding that in. You'll see it's kind of like a snug somewhat fit. Somewhat. Problem is this is loose, so hopefully it'll be okay. I'm just going to bend it a little bit and hopefully it'll stay in there. Next, we've got to connect the anode over to the actual resistor itself. Now I could just wrap the resistor around, and you can still see that this is not holding in there that tight. I could then like take the resistor and I could wrap it around so that it's just touching. Boom. It's just touching this instead, but I'm just going to go and use another cable to make this more complex. So in this case, I'm going to take a slot to slot. I am going to steal the red one. Since we're going to power, doesn't really matter, it's arbitrary, is that I'm going to then put that onto the other side of the LED. Oh, I grabbed sacrificey. I should not be doing that. Let's grab a different one. So again, because otherwise the circuit wouldn't work. So let's get that in there for cathode, the anode then going here. Okay. So hopefully those two are connected. Boom. Next, on the other side here, I'm going to take the resistor and put it into the slot. And hopefully that stays in here. And you can see why this is finicky. Like, notice how everything's kind of sliding and falling out. I'm doing this purposefully to show the difficulty it have and why you would just use a breadboard in the actual end. So what I'm going to do next is, okay, I've got the resistor, and I want that to go into the actual positive. So I'm almost connecting all the power and everything else together. So I've got that plugged into the positive for the battery, and it's getting messy. Okay, I've got the LED. Okay. Let's get this LED back in here. Okay, it's slotted there. And then hopefully this works. And I'm just going to connect it to complete the circuit on the actual negative. And it did. But it's a big old mess, and it's hard to actually see. To make this maybe a little bit easier here, like, oop, you can see it like disconnecting and being finicky. You can see the LED lighting up that you have here. You can see it versus one that's not. But like, notice how annoying this is. Like, look at this. Like, look, trying to connect this up and do this yourself. Normally you'd be soldering it, so this is not a nice way to prototype anything. This is where the breadboard's going to come in and make this nicer. But other things that you can notice is like finicky stuff that could happen, moving the cables and what happens, and like flickers you would see that are not like consistent. What happens like if you had a short going over everything as well? Like anything that touches going across that could cause issues. So like even me touching it. So not the funnest. You got the basic circuit, there's the start, and you have it flowing again, being the volts you have here. You have the current flowing through, which would be flowing through the actual red. See, I use the red for positive. Up here through the resistor, up through the anode of the actual LED, down, and it's being used and giving us some of the light, and then down back through the cathode, back to the negative, and it's just going to continuously keep going until no more power. Okay. Okay, now I could take this out right now, and let's just go even test sacrificey. We started with to see, like, well, there was a pop. Did it actually destroy it? Was I just thinking things? So again, anode going in. And again, I hate this. It's all finicky. Okay, cathode, anode, and nothing. So you can see it's dead. So by hooking up, so you may not even notice that you've done it, but you could be sitting here like, why is nothing working when you're building your circuit? And boom, look what happened. So I'll take that out. And just to see demo that it wasn't something else I've done, I'll put back in the original LED, doing the bad way that everything's powered up, and I can see it's powered up. Now to demo the other thing is, well, again, this is being a diode that we have the anode, the cathode in the proper way. If I am to switch this around, you will then see, hey, look, no light. So once again, you have to make sure that you've got your LED the right way from the anode and cathode, the way it's flowing. So the positive going through the anode and the negative going to the cathode, and being that anode again being the longer lead. Ooh. And we're back, and there you go, you got the light. So fanciful. So take all this stuff out. I'll disconnect everything here. I'll get my mangled resistor and set it to the side, and I've got my power source, and I've got my other cables. Well, after all that, you can see how finicky and annoying that is, and then why that is going to be a lot nicer to actually use in the end. This is just for prototyping. So I'm going to do the same thing again, and I want to set up the same circuit, but want to use the breadboard. And really, I just have to know how things flow and create the same circuit. So I'm going to start by putting in the actual resistor, or the LED first, and just making sure which side I put in the anode and which side I put the cathode in, to remember that, again, that is supposed to be where the positive power is going. So mistakes that some people do is they automatically just, okay, I'll just slot that in. So see that's straight. You can see it's going in here. And the problem is it's on the same row. You can see it going internally that they're on the same row. So really now you've connected the anode to the cathode, because along that row inside is a piece of metal where everything is connected together, so the flow. And so this is the improper way to do it. You want to, when you're going in between two devices to make a circuit, go between two rows. Doesn't matter if they're close or apart. Sometimes I'm just going to do it a little further apart just for ease of getting stuff in. But I'm remembering again that this side here is the anode, this side here is the cathode. And so I'm just putting it between two rows to start my actual overall circuit. And I can bend it down some just to make it easier for you guys to see. So you don't need to do in the same rows, it doesn't matter. All I have to know is that this row, let's do it here, is this row right here is the actual anode. And then this row is where I put the actual cathode. And I can connect anything to here and anything to here to complete the rest of the circuit. So there's lots of different ways to start doing this. So the next is I need to take that same resistor we had before and I need to add it into the circuit. Now, compared to doing this with the simulator, I'm going to set things up slightly differently. Is that, okay, well, before we had right here is the power. I'm going to do it off the cathode this time. It doesn't really matter for an LED which side you do the resistor from. But I'm going to put it in here and then arbitrarily put it in on a different side. Doesn't make it for the prettiest of circuits, but I'm just getting each side in, making sure that it's making connectors. So you can see that closer up, go from the actual side. So resistors, doesn't matter which direction you actually put it in, but the important part here is the fact that I have it one side in the same row where the cathode is. I could put it on the anode, but at least I have to have it on one side just to slow because the flow, so the amps that are going through the entire circuit. So the idea is here, it'll come up through the resistor, well, it'll come up through the anode, through here, go through. And so these two sides are connected together because they're on this same row. Next from there, I want to start dealing with the rest of the power. And so I want to start bringing in some of the actual other jumpers. So this is where you start digging through your wires, finding what you want, maybe start with some smaller ones and it could get messier. But for the anode, I want to have the actual power. So anywhere along here I can plug in. I could go right here or right here. It really doesn't matter other than how you're making your circuit clear. And then I'm going to plug it down here at the bottom. So again, you can see it there. There's from the side is that I have got on the same side we have the anode. I have it connected in the row, so they're connected through the actual breadboard here. And it's going through the wire. And right now I'm just putting on the positive row because I plan to connect the positive side of the power source there and the negative side right here. And all of these are shared. So last part I need to then take for the negative. So you want to go get a black wire. And again, for all these, I'm just using the two, again, M to M side, two jumpers. So going from the same row, we have the end of the resistor, and then this time making sure that, boom, it's there on the negative. So far what we'll get is, I remember that when we hook up the power, it's going to run down through here, up through the red wire, continue through the breadboard, go through the anode in the LED, which will light up, down through the cathode, down through the actual resistor, then out through the actual negative. And the idea is the resistor could have been on either side. And I know I've switched this up some, but the idea is it doesn't really matter for the case with the LED. It's the fact that this just slows down the overall flow going through the actual circuit. Next, now I want to hook up the actual power source. So we have this case, I am just using still, boom, the trusty one we had in the very beginning. Now this one isn't as nice to hook up because again it doesn't provide where I can just, hey look, just plug that straight in, and I don't have any jumpers. So for the slots I'm going to have to use again some of our jumper cables. And so finding another red one and another black wire, just because I want to keep this consistent. So from the positive side I am here, and then the negative here, Just remember to do these things on camera would be nice. So just making sure the red to red, black to black, and it's just easier for me to remember. And now I've made like the connectors, and now I can go in for the positive and then the negative. So I can put them anywhere along here, doesn't matter. I just like doing it at the end, and there we go. We have our LED running, lighting up. And so again, the idea is that we have a closed circuit right now, that we have our power source of 3 volts, and the amp's added in. It's going out of the positive, so we follow from the red, going down through to here, through the anode, through the LED, back through the resistor here, and then back up through the negative and completing that overall circuit. If I was to take out the black, well then we have an open circuit, so the light's off and not actually working. So we put that back in. So, fun for setting stuff up with the battery. So this is the basics of working the breadboard, basics of electricity. The idea is getting used to and playing with these. So if you have the kit, I suggest like do stuff with the simulator, following from like what they have for their diagrams. Come down to the actual kit itself and start playing with it here as well, and get used to physically putting the components in. The fact that you can start getting short circuits in what happens in different ways. You can start connecting stuff together, and the fact that you can just see like when starting to do this breadboard stuff, it's going to get like confusing with the wires. So how you choose them and how you put them and the color coding and your placement can be done just to make your life easier when you're prototyping all these things. So I want to do a few more things and see how we can start demoing stuff. So I'm going to take off these power sources. Now I'm taking off the wires here just so that if they were connected, I don't want them flopping around and then touching each other in the end. You're going to get that short circuit. So I'm removing those, and even the end, like this should be okay, shouldn't be touched, but you could just remove the battery to be careful as well. What I'm going to do now is just demo for other people that maybe don't have batteries today or other things, but this other duohimigi that comes in the actual kit itself. And it just handles dealing with the power in different ways. And the idea is it's designed to go onto actual breadboards. You'll see that you have the pins on the actual bottom right here. They line up with these outer sides for power as well. So you should be able to put them, you can see I'm making sure that it's completely in there on both sides, not just pushing it off on some side, making sure that they line up, and then just shoving that in. It'll be kind of stiff. Boom. So you've got it from that side in the actual board. It's making metal to metal connectors. It provides different ways then of hooking up power on this side, and provides a nice on-off button so you could leave your battery connected. Now the idea with these is you can see lots of other things on here, like it's got its own LED. You can see those little tiny resistors right here and other chips. You have other cases here for power, which you can use to hook up other things as well later on if you're using servos or things. But then what you have for these outside is you have these little things here that are called like little jumpers. It's just insulated material, and there's a piece of metal in between, and it's connecting from right here. And this is just so that you can select and say, well, how much power do I want going, say, down this side of the breadboard versus this side, like this side versus this side right here. And the point of that is some things just need 5 volts, some things need 3.3 volts when you're working with some Arduino, so some of the sensors. And so maybe you have one side that's giving 3.3 volts and one side that's giving 5. And the way that you select that is knowing, well, okay, what's the connector attached to right there? So you can see the jumper going in between, and it's on the side that says 3.3 volts. And so if we want to have 5 volts, and see we're matching up over to here for this side, that I've got my positive and I've got my negative, and I want to have, say, 5 volts instead of the 3.3. You can see right now, looking closer, and you can see it's on the 3.3, is that we just select take this off, move it over. So I just pop this little thing off that's here on this side, you can see like that, and I move it over so it's connecting these 2 wires here. And you're giving it power. It also has the off, so you could just put it in between if you don't want no power going down that side. But here I'm just going to put the 5 volts just to demo. You could have left it at the 3.3 for what we're doing, but just matters for stuff later on. So it means now that this will connect for the power. It's going to the same, that we have our positive and we have our negative that we are working with. But now we need to give it power, either something connected through a barrel jack, or we start connecting it through USB. And I'll do both. And you have this little button, which is an on-off right here, and the light up for having power. So right now I have it, if it's down, it means power on. If it's up, right there, it means that there's no power. Now I'm going to hook up our 9-volt battery. So boom. Boom. And then plug it into the barrel jack connector here. So it's connected. Nothing's running yet, no lights on, because this thing provides a little button that allows you to turn on and off the power easily, which is a lot nicer than when I was manually connecting this in myself with the other power that we had here. So if I go on, you can see that LED in here is on to indicate that the whole thing is power. So you know that that has power indicated, and you can see our LED is now on when doing that. So we are drawing our power. So a nice little thing to use when building our circuits. And also later on, when we're working with Adrenos, we have some power from the Adreno, but maybe for some things like motors and stuff that draw more, we'll have a separate power source. And so we could demo with this. But even while I'm doing my work is, okay, well, I could turn that off, do my work with the circuit, and then go back and put this on. So right now for LEDs, it's okay, but imagine you had a motor and you want to do stuff. You don't want power going through in the motor and stuff happening. You want that off. So that's with the barrel jack connector. Now, after that, boom. Then this thing right here, as I said, is just being plugged in for, like, you just have to have power going plugged into the computer itself or into another power source. So fun from there. Let's see, anything else that I wanted to do? So, yeah, the connectors to the computer. Yeah, so you have a lot of different connectors and what you can do to build this up. Now I want to demo one thing I didn't have, and we'll see how it goes here. When we talked about in the class first lecture notes was load. Is that really, we're just with a resistor, but really this is the one thing right here. Your LED is the one thing that's consuming power. It provides a little bit of resistance, it eats up power, but that's the one thing we have for load that's on here. But what if we started adding more things to the overall load itself? So I put it back here for the actual power. We can see our LED here and what starts happening if we increase the load and add more work into it. So I've got the light on right now, but what if we started putting a whole bunch of LEDs in a row? So I'm going to leave this one down right here and see, well, what starts happening when we add more things into the actual overall circuit. So I'm going to have to start moving stuff down. I'm going to just arbitrarily move the negative down from right here. I am going to move the resistor in line right here. Okay. And we'll see how this goes. So far I'm changing the circuit. It's an open circuit right now. It won't flow because even when we have here from the actual positive, it's going to flow, but it's like positive, go through the actual red, anode, cathode, and go down here, but there's nothing connected along here, so it's an open circuit right now. But we have the other components so far of the negative, which is connected, and on the same row right here, it's hard to see, but it is on that same row. I just got it bent. And it's going through here to the resistor. Now what I want to do is I just have some other LEDs set up here already. So I got 3 other ones, and so what we're going to do is put them in series, which means it's one after the other after the other. So it's like power going through one, it eats up, then what power is still pushed through is going to the next and going to the next. And so we want to remember again that short end of these is the cathode, then the long end is the anode. So I'm always making sure to connect in that same way so we're not stopping the flow. So on the same row right here to another one, just putting these in, and I'll bend it down, is that getting that in at least a fair distance. And now what I'm doing here is this is in the same row as the other side of the resistor, so this is still the negative, and making sure that's flowing through to the actual anode. And I'm going to keep connecting up 2 more of these, but I want to make sure by the end that I have the last one or something connecting down to there. So we'll go with the red one next. So we want a positive to negative, so I'm still making sure that I have the cathode. So here, I should have probably done these closer. We're going to see where I use a jumper to do it. So I am then connecting at the end of another one to the next one. Here, I'll just put some right here in and then do the rest. So we have cathode, anode, and I'll put a little wire. Okay, that one. And then we have another one. Cathode, anode. Oh, cathode, anode. Always going cathode, anode, getting them in there, bending it down so that they could be seen, going in the circuit. So things are still not connected in between here. We just have the resistor to this one. I move them over just so I can then now start using some other arbitrary wires. So I'm going again, we have the cathode, anode, and so the anode of one connected to the cathode of the other, still the same flow, and using now just another wire. So you can see from right there, hopefully, that I'm getting the flow that's through here, through the resistor, into the LED, back down to this one, which is on the same row as the anode, going over to the cathode of the other one and going through it, and then repeating that process. So same row of the anode of one being sent to the cathode of the next one. Boom. And then finally, let's go with a blue cable, is we will go from the anode of that one to the cathode of that very first one, and this should be closing our circuit. We just have no power yet. So the overall idea of this one is that it should be flowing from the positive, so from right here, going up to the red through this LED, through the blue wire, then through the yellow LED, through the white wire, through the red LED, then through the green wire, through the blue LED, through the resistor, and then up and over and back for the negative to complete the actual overall circuit. And so now we've loaded up 4 different components onto this entire circuit itself, and each one is eating up the actual power. Now, we may not see much from this, but the idea is that my hypothesis would be that this may be starting being the brightest, but then this will be a little bit dimmer, a little bit dimmer, a little bit dimmer, or they'll all be dimmer overall, depending on how much power as you go through the rest of this. So I've got the battery, I've got everything off, and then let's see if I turn this on, what do we get? We get none of them lighting up. Awesome. Awesome. That's that first thing then, to figure out what's going on. Okay, this is fun. This is why I'm doing it even scripted, and I like screwing up, because you're like, well, what if you're doing the same? What do I start doing to figuring out why things aren't there? Well, I know if the light's not going, we have the power, we have everything else. One thing could be is that there is a short circuit or a break. For the resistors themselves, is that, or for the LEDs themselves, is that, are they in the right direction? Is everything connected from there? Or 2 is maybe there's like too much load in here that nothing can really pull power. There's not enough, like say there's such little current now flowing through here that nothing is turning on. So I could start testing stuff to see, well, okay, well, what will work? Like, let's take out and break some of this circuit for right now, and say I'll move things over, turn stuff off. So I'm just going to move the resistor over itself, put that in there. Okay, let's get the resistor in first. They're always annoying to get in. And then right here, so boom. Boom. And so I'm just going to try one LED in the beginning and see how things are working. So connect to the negative power and get another cable just to test with right here. And I'm just going to try to connect from the cathode all the way to the resistor down here. So now I've taken these things out, and it's going to turn on and see, okay, good. So, well, that is working. So that LED is working. We do have the power, just bypass the circuit, and none of these things are in there at all anymore. So none of these are connected. So that's one. Okay, I'll turn off the power. Let's try the next one. So let's reconnect the anode of this one right here over. So I'm going to take these other wires out. I'm going to check, okay, well, which one is the longer lead again, and make sure. Okay, well, I've got the anode here, and I've got the actual cathode. So putting in here, so I've got cathode connecting to anode on this side. Okay, and then connecting off of this to the actual resistor itself. So I'm just adding in one more of them, and now trying to turn that on. Hey, look at that. That does work. We have two of these in here. But notice something is one's brighter than the other one. Like, you can see that. Like, why isn't the green just as bright? Like, we had that working before. Oh, what if we change this? Try to put this over here, just put the resistor, and just get it back to 1. Okay. Got that level of brightness here. Okay, take that out. Put that back, include this one right here. Oh, still dimmer from the first time, but one's brighter. So the idea of that load and what's eating stuff up. So let's go in now and turn this off, and now add a third thing into the load for the actual circuit. So cathode here, now going to the anode from one more, and then bringing in that the end of this cathode goes to our resistor. Okay. And nothing. Even though it was just working before. Maybe very dimly, if like I don't even think it'd give anything, even if I turn off like all my lights here. You're like, no, it's nothing. But we just had it working. So this is just a live demo of the fact of like what load does. That even though we had this all working, everything should be fine within the actual circuit itself. That like, okay, well, got the anode, cathode, everything is connected properly. You're like, nope, still not lighting up. And so it's a problem that you have to worry about if you start connecting too many things. And you can see me tracing through this that, okay, well, we're not getting enough amps to run what we're doing coming off of this 9-volt battery to have all of these connected up. And the fact that doing in series just won't work. And maybe we have to connect it in a different way to start getting things. So they're all pulling their own power and doing it in parallel and sharing some. And so this whole series doesn't work. Okay. I think 42 minutes is long enough from right there, but just seeing the difference of what happens even when you're working on the simulator versus working with the physical equipment and setting this all up, and the finickiness of trying to manually connect everything to then using the breadboard and having your power sources. So following after this, again, if you've just watched this video, please also go back and watch the simulator video. It all connects together is my hope and adds to what you're learning. Next, we'll be going into the Arduino, so getting to the controllers for the actual robots. And I hope at this point in time you're all still doing good and not too stressed with the semester and keeping up with material and continuing to be good people.